The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to this Better Buildings Alliance Healthcare Sector Peer Exchange webinar. This one is titled Lighting for an Improved Environment of Care. I am John Jameson, Healthcare Sector Account Manager with Better Buildings Alliance, and I work with ICF International here in Washington, D.C. Today, we have two panelists joining us. Slide here. Two panelists joining us, and we'll be discussing lighting and making it a top priority within your organization, how to make that argument to different internal audiences. So we'll be hearing from John D'Angelo at Northwestern University, and then we'll also be hearing from Michael Meyer at Pacific Northwest National Laboratory on technology guidance and some lighting campaign opportunities through the Better Buildings Alliance. And here you'll see a little bit of background on each presenter. John is now with Northwestern University, but has 27 years of experience ranging from the U.S. Navy to New York Presbyterian Hospital and Cleveland Clinic. And Michael Meyer as well from PNNL, a lighting expert with our Alliance lighting team. I'd like to ask that folks save their questions for the end of the webinar. We'll have about 15 to 20 minutes reserved for question and answer. So please save those questions until after John and Michael both present, and we'll be happy to answer those at that time. And this time, I'd like to turn it over to John.
Hey, thank you, John, very much. And if you could go ahead and advance the slide. For those that are listening in, thank you very much for joining us today. One of the things that Michael and I talked about was we believe that the majority of people in the facilities management organization understand the benefits of higher quality, lower cost lighting, but we often have great difficulty in getting the financial or the organizational support to move forward. But I figured I would take a step back, and when I started my career as a facilities manager, I would have had a hard time putting lighting in my top 10, especially when I started in healthcare. I was looking at outcome, safety, experience, declining budgets, aging staffing, et cetera, et cetera. In fact, if I listed lighting as an issue, it probably would have been somewhere about 20 pages away from my top 10. John, could you go to the next slide? But over the course of especially my Cleveland Clinic experience, I started to understand how lighting was really part of the majority of my top 10. And so I started to try and find a way to, one, convince myself, and two, to use that to help message improve lighting for the various stakeholders within the healthcare. So when I talk to administrators, I would talk about circadian rhythms. When I talk to nurses, I would talk about HAI. When I talk to physicians, I would talk about consistent visual presentation. When I talk to surgeons, I would talk about how I could make them a little bit more comfortable within the operating room. And for those of you who have already made the switch from traditional source surgical task lighting to LED task lighting, you know that underneath the light it's a lot cooler simply by the means on which LEDs get rid of their waste heat. When I talk to the millennials, you know, we start talking about carcinogens and asthma from airborne particulates. If you go to the next slide, John. So from an outcomes perspective, that really allowed me to message. From a safety perspective, as I started looking into how lighting led to safety beyond the traditional that we all know from slip and falls, you can prevent a lot of issues on slip and falls by having good lighting on the floor with solid maximum to minimum ratios. In other words, you're removing a lot of the shadowing. And especially as you have an older patient base, making sure that you have good visual presentation along the walls and anything that could become a trip hazard. As we get older, some of our spatial orientation is not the same as when it was young. And lo and behold, while I was at the Cleveland Clinic, I found that the worst healthcare fire happened at the Cleveland Clinic. And as you can see from the little blurb, 123 people were killed. And the root cause of that fire was a bare light bulb. When I started putting the message together to talk to my chief financial officer and my chief operating officer for the funding and for the inconvenience of operations in doing a major lighting, what we started really looking at was the reliability, the recoverability, and the capacity benefits of going to higher efficiency lighting. So most hospitals were built between the 50s and the 70s. The majority of those hospitals have dramatically increased the amount of electrical equipment, and very few of those hospitals have changed out their transformers, or the utility companies have changed out those transformers for them. So dramatically reducing your lighting load really does allow you to have higher reliability on your electrical circuits, greater capacity for new construction projects. You know, when we did this at Cleveland Clinic, we were able to put more things on our existing generators just from the reduction in load. We had a similar experience while I was with New York Presbyterian. We upgraded some of our main corridors, and instead of going with every third light on an emergency power circuit, we were actually able to string every light on the circuit, and we still had additional capacity left over on the generators. The stuff on the right-hand side was just fun with an infrared camera. I had a restroom that had the traditional incandescent lamps on a makeup mirror configuration, so I played with my infrared, and as you can see, the hot spot on those incandescents was 203 degrees in the second picture. On the third picture down, I had actually unscrewed with a glove, because they were so hot, the incandescents, screwed in LEDs and turned them on. And the way this particular camera, the mode that it was in, it assigned the hottest thing that it saw a red, and the coolest thing that it saw a blue. So even though those LEDs in the third picture are turned on, the hottest thing in the room is actually the waste heat from the old incandescent lamps coming back out of the wall. And so if you follow the timestamp to the bottom photo, it took about an hour for the LED lamps waste heat to become the hottest thing in the room, the wall itself to cool back down, and you can see between the third and the fourth picture that the LEDs were burning at 99 degrees from the beginning through this entire series, as opposed to 203 degrees for the incandescents. John, if you go to the next slide. So my top three have always been patient outcomes, patient safety, and patient experience. For those on the line that are in healthcare facilities, you're fairly familiar with the ANSI IESNA RP29. The updated version is actually about to go out for public comment. The team has really been working very hard on that, and there's a lot more in the updated version of the RP29, which is lighting for hospitals and healthcare facilities, than there was in the 2006 version on patient experience. And the three big that you have up there: control of lighting, the quality of electric light, and most importantly, we've done some experiments at both Cleveland Clinic and at New York Presbyterian on giving dimming capability to the nursing units. Is probably the single most effective way to control noise on the unit. There's something that is inherent in all of us when we walk into a church or some other dimly lit area that we start to naturally moderate the volume of our voices. And we've proven that over and over and over again, that even somebody coming from off of the unit, when they walk into a unit where you've dimmed the lights, it automatically makes them much more respectful of the noise that they're making. Next slide, please, John. So a couple years ago, Department of Energy had sponsored an advanced energy design guide for healthcare, and the charter on this through ASHRAE was to using only commercially off-the-shelf available technology, design a hospital building based off of an actual hospital design that met all of the same services and sizes of that actual design, but did so at a 50% of the energy usage of that existing hospital. And in doing the studies, Department of Energy was able to find that the interior lighting in healthcare as a percentage of your total energy use, that's diesel, natural gas, and electricity, ranges between 8 and 10%. So if you assume that you're one of the average hospitals, that your total energy bill is about 2% of your hospital budget or about a quarter of your facilities management budget, and that you can cut your lighting in half, that's about a $50,000 a year savings on every $1 million of energy spend. It is not an insignificant amount of money, since most of us are in the several $1 million energy spend category. John, next slide. These are exact excerpts from that Advanced Energy Design Guide, and as you can see, these are really not some future generation that maybe it will get invented. These are just opportunities that you can pick and choose from. You don't have to do them all. You can pick and choose from those that fit within your culture and within your desire, but each and every one of them is proven to reduce your total energy demand. Next slide, John. From the lighting power density, you can see a whole building of 0.9, and at the time, that was their base requirement in the 90.1, which, as most of the people on this line know, that's a prerequisite to even consider for LEED. So 0.9 watts per square foot is not a strong reach, and just designing to the code minimum allowed you to do major savings. And you can get there a lot of different ways. You just have to make sure that we are much more thoughtful about lighting being a part of our integrated design and not an afterthought. Next slide, John. So I had an opportunity that was a lot of fun while I was at Cleveland Clinic. The Advanced Energy Design Guide had just come out, and we were building two large family health and ambulatory surgery centers, and we had just come out with our energy standard for Cleveland Clinic. And so our two designers and our two contractors for those two different awards both got the same standard. The two family health and ambulatory surgery centers both had very similar missions. They had very similar services. As you can see, their sizes were the same. And the way those design teams approached meeting the Cleveland Clinic Energy Standard is written out there between insulation, lighting, HVAC. And what you're able to see is, just using that Advanced Energy Design Guide as a basis, the one design team was able to do or achieve a 25% improvement over the 90.1, and the other was able to achieve a 16% improvement over the 90.1, and both did it within the program budget. It did not come as a cost penalty. It actually came as an on-budget initial cost and a long-term maintenance and operations savings. Next slide, please, John. So I am going to go ahead and turn it over to Michael, and we will be available for questions at the end.
Thanks, John. Moving on to the next slide. I'm going to present on a couple of different things. As John Jay mentioned, a problem with having two Johns on the phone, you have to distinguish which ones you're referring to. First, I was going to discuss the LEED campaign, which is about lighting, energy efficiency, and parking, and then broaden it to some exterior lighting comments in general. And then we move into interior with some interior lighting and some specifics related to daylighting as well as electric lighting, and some of the benefits of those and some things to consider. And then finally moving on to the Department of Energy as a co-sponsor of the interior lighting campaign, where we're really focusing on helping people achieve more savings in their interior lighting as well. Moving on to the next slide, please. I always like to, I happen to quote John here, even though I know he was presenting, but I actually quote John often about patient experience. He always told me a long time ago when we were working on projects together at the Cleveland Clinic about how patient experience starts as they arrive. It's not when they walk through the door, it's the parking lot. It's that whole experience, and ultimately how I always found interesting how that affects the scores, and you all know that much more than I do, but I always found it interesting about how comfortable they feel as they enter it can affect their perception of how well they're going to be serviced at that hospital or healthcare facility, and that might affect your Medicare scores. So it's always good to remember that. And the reason I start with that is that we found that when people go do relighting in parking facilities, it's actually enhanced their experience. So I'm going to tie back into this is the Lighting Energy Efficiency and Parking campaign. It's a national campaign that's supported by Department of Energy, BOMA, IFMA, and the International Parking Institute, as well as Green Parking Council, encouraging people to consider either new construction, high-efficiency parking solution, lighting parking solutions, or to retrofit something that they currently had. And a great example of this is, again, with the Cleveland Clinic, that project I was talking about that John and I worked on earlier. They had actually had a parking structure that was using a high-pressure sodium that was on the sample on-off setting, and they converted it to LEDs that were on occupancy sensors. And at the time, there was some concern about what the perception would be both on the security staff as well as the patients of the occupancy sensors. And they found even one time while they were doing some field tests of the potential products they were evaluating, that one person parked up on the 5th level where they were testing the lighting out, not because it was they drove through every empty level and they got to the lighting where it was now being renovated because they liked the appearance. They thought it was better placed. So they actually sought out the better lighting to park, even though it required them to drive up multiple more rows. So I think that's just interesting about even how it affected them in a parking structure. Multiple healthcare facilities have been recognized in Phase 1, and we're about to announce our Phase 2 award winners at the end of June. I don't want to divulge who they are or what their energy savings were, but a couple of healthcare bodies across the country did a significant number of savings in the second phase, and they'll be highlighted soon. Moving to the next slide, you'll see what one site did. This is Theta Care, which is the name of the organization. It's their Appleton Medical Center. They had metal halide, and they converted it to a low wattage LED, and they were able to recognize 86% energy savings. This is a Google image of a high level of what the exterior facility looks like, not the specific parking structure itself. The power density, for those who may not be familiar with the term, is watts per square foot. This is the amount of equipment and the power it draws divided by the total area. 0.22 is about what many current parking structures are. Depending on the energy code you're in, it could be as low as 0.19, but that's a pretty standard run-of-the-mill, not really working hard. They worked very hard, and they got it down to 0.03 watts per square foot. And this resulted in a $16,000 annual electricity savings just at this facility alone. The other advantage, and this is something that we always like to remind people, is that typically when you go from metal halide to LED, you're going to pick up a longer light source in the process, so that deferred maintenance is saving you money as well. So it's not just the electricity savings. We didn't have the actual maintenance savings available to help calculate that out, but it's always something to remember is that it's not just about the electricity. It's about the sending staff out there to have to replace the lighting. Next slide, please. This is a parking lot in Vaca Valley, California. Why I like the juxtaposition between this and the previous slide was that the first one was a parking structure, and this is a parking lot. And again, here we're seeing about a 58% energy savings. And that's significant because in a parking lot, they can't use controls as well. most parking lots can't use these controls as well compared to a parking structure, as well as the operating cycles are a little different. So therefore, it limits some of your savings potential. But this site, through the use of actually very aggressive lighting controls, was able to see almost a 60% energy savings. You'll notice that, again, the power density here has gone from a 0.07 to a 0.06, and that's not a significant change. And the reason is that they really actually just replaced only a certain number of light fixtures, but in the process of changing those light fixtures, they added in a series of new lighting controls. And in the process, they used microwave controls to detect motion. So the idea here is that when the exterior lighting, when there's low occupancy in the parking lot, the light levels actually reduce the output. So again, you're saving more energy. And so that's why the energy savings number is significant, but it doesn't look so with the power density number change. They're seeing about a $1,200 of electricity savings as well. So it's significant that they are able to save that as well. Next slide, please. The first keynote thing here is that parking facility lighting just should be replaced. Most people are using still outdated HID lighting. This is a dying technology. Its shipments every year diminish. Manufacturers are not looking at ways to make it any better. They're looking at ways to walk away from it if they can. When you consider new lighting, you're going to probably get better uniformity. And better uniformity means that you can actually achieve better results with less light. There was actually just a research paper published last week that proved that as well. So it's not just kind of a math mumbo jumbo. It's an actual methodology. So by making a space with less bright spots and dark spots and an overall uniform blanket of light, you don't need as many lumens. That actually allows you to save energy just right off the bat. Also, with the better quality, patrons and security staff alike. When you even hypersodium, that orange light that we all know is kind of dingy. At Cleveland Clinic, we heard that they really liked the higher color rendering of the LEDs. They were able to tell out cars differently. Security was able to distinguish different people wearing different shirts. So the color people like, it enhances the appearance of the space. Even metal halide, while it is a broader spectrum source, it still has some color issues. So some of the newer lighting, LED, but even some non-LED sources, have much better color quality characteristics than metal halide, so you save energy that way. Then the new lighting also just helps save money and energy. The other thing that I would talk about with your exterior lighting is that we know, and this is recently published by the IES, and I've said IES a couple of times, but if you're unfamiliar with the organization, it's the Illuminating Engineering Society of North America. It's a trade group in the United States. They ultimately publish recommendations for lighting, both interior and exterior, as John mentioned, RP29 is coming out. In their most recent document for exterior environments, they stated that the effects of light on humans, other animals, and plants, while much more research is required, the overall negative impact is not in doubt. Essentially, we know that we're having an effect on our environment because we're lighting at night. And if you can reduce some of that negative effect by reducing your light levels, then you're actually reducing some of the need why some of the people might be in the hospital from get-go. Also, you're not blasting light through their windows by using better lighting. Next slide, please. So the Department of Energy has a Better Building Alliance, which you're all familiar with. On their website, which are listed at the very bottom of the specifications, there's a high-performance parking structure lighting specification, a high-performance parking lot specification. There's also a wall pack specification here. If you may be familiar with that term, a wall pack is a wall-mounted fixture, kind of tends to blast a lot of light, and sometimes that's an efficient way to do it. So it's a specification and application guidance, which will provide information on how you better apply certain types of fixtures, when to light, when not to light. Also on this website for the Department of Energy specifications includes exterior control guidance. Controls are gaining a lot of momentum, and a lot of people are interested in them, but the real question is, when you're considering for exterior lighting, what type of protocols are you looking at? How to use them with different light sources? So if your healthcare agency is considering that, you might want to look at the controls guidance. Finally, the second to last URL at the bottom of the page is for the LEAP campaign. I've mentioned it a couple times. If you are interested in exterior lighting or parking facility lighting, the website provides information about resources where you might go find more information, such as case studies, possible incentives, a couple of different tools like a financial calculator and some other lighting tools, as well as we still are able to provide a limited amount of technical assistance. So if you're interested in a question because the vendor keeps coming to you and saying this is the greatest thing since sliced bread, we can provide some unbiased technical feedback on whether or not some of the claims are worth merit, or whether or not you should be asking other questions. But you have to go through the LEAP campaign so we can document that. So that's the official way we can help provide some technical assistance. Moving from the exterior lighting into the interior lighting in the next slide. I thought it would be fun. John mentioned circadian rhythms. We spent a fair amount of discussion on circadian rhythms in grad school, and it was really worth talking about because from a lighting perspective, in the last 3 to 4 years, it's by far the one thing that everyone's talking about more and more, partially because the research out there is getting better and better, and we know directly what some of the effects lighting is playing under circadian rhythm, but also it is now becoming a manufacturer pitch point is the best way to describe it. So I thought I'd just quickly talk about circadian rhythm and then touch base on some of the research that we're seeing related to that. So essentially it's your 24-hour cycle that affects sleep and certain hormones. Light is the single largest Zeitgeber, and Zeitgeber is just essentially a nice, fun German word for timekeeper. It's essentially what tells the body to when you should be getting up and when you should roughly be going to bed. But it's a complex series phenomenon, so that it matters when the light exposure occurs, and also the intensity of it, as well as the spectrum. So if you get up in the middle of the night and you turn on the lights in the kitchen to do something, that is affecting it, versus if you get up in the morning and turn on lights in the kitchen, that affects it differently. The spectrum matters a lot. That's why you often see red lights over blue lights. But again, it matters what time of the person's cycle the light is being administered. It's, as I mentioned, an area of significant current research. And the key thing I wanted to mention is that it's an area of potential sales and marketing, and that's where I'm a little nervous that people are claiming that this fixture might help people, or some of these benefits. And while there's some early research suggesting there's a relationship, I would be concerned of someone saying that this is going to affect it in a positive way, because we don't entirely know when it's going to work. There are light fixtures that are called color tuning. These are essentially what we call shades of white. They allow, and LED is really the best type of technology that can do this. It's a light fixture that can start out such as at a low color temperature around, say, 2500 or 2700, which is your amberish color, and then you can, through a control system, you can dial it in, and it'll move all the way up to, let's say, 6000 Kelvin, which is your blue, very blue, almost more even blue than some elements of daylight. And the idea is that depending on when you want the person's circadian rhythm to be entrained, you would essentially make it maybe, say, the high blue content in the morning, and then through the later day you might change color tune during the course of the day to some of the lower Kelvin, so again you're not affecting their circadian rhythm differently. There are potential benefits, but the claims need to be verified. And the other key detail here is that the solutions might be person-specific. So again, it's very nervous to say that this is one protocol works for everybody, or at the right time. Next slide, please. As I mentioned, there's a lot of research going on, and I thought this slide would just be a quick overview, again, because I think in some cases it might be a sales mechanism, I don't use the say sales mechanism. It might be leverage for your organization to upgrade your lighting into your management. If you said, hey, we know there's some interactions here, we can get energy savings, but also you might be able to see some ancillary health benefits. So here's some of the things that people are talking about. Again, the health professionals need to weigh in on some of the exact applications of them. So University of Toronto, Northwest, found that bright light associated with extreme visceral good and bad emotions. NARA School of Medicine, they found that nighttime light is correlated with depression and metabolic anomalies in the elderly. Schools in Europe, London and Munich, found that blue light can activate type 2 drugs in pancreatic cells. And then Tulane is finding exposure at night appears to negate the efficacy of cancer drugs in rats with certain types of breast cancer. And then Northwestern also has found that light exposure in the morning is linked to lower BMI. So I don't know if your health organizations are instituting, environmental protocols along with their medicine, but if so, they might want to start considering some of the lighting, and here's some of the early research. And again, I said this might be a lever for energy efficient upgrade. Next slide, please. I thought it was also worth discussing about daylighting. John mentioned daylighting briefly in one of his slides. I like this slide really quickly because CBRE, which is a pretty large national commercial developer, this is a tweet roughly a year ago where they were talking about daylighting improving healthcare. The fact that major developers are focusing on daylighting is great. That means it's no longer do hospitals have to be windowless rooms. Even in one of the examples they talked about where a surgeon actually requested daylight for their operating room. I've been in a handful of surgical suites in my life, and I've never been in one with a view window or access to daylight. So I think it's interesting that the surgeons are asking for it. And then also I mentioned that healthcare research is, again, we're finding that there's a relationship to daylighting related to depression and reducing time in hospitals. So again, that idea of daylight that is being brought in, let's actually look at some of the other tangible benefits to it in addition to the energy savings. Obviously, everyone always talks about pairing it with daylighting with lighting controls. So now that you've brought the daylight in to either the patient room or to a common core or a hallway, if you don't put a daylight sensor in the light fixture to reduce some of that lighting, you're kind of wasting all of that energy savings that you're gaining through the daylighting. While there are ancillary benefits, it's really important to think about some of the energy savings as well. Next slide, please. As I mentioned, some of the ancillary benefits. So this is an actual natural experiment. A hospital in Canada started discovering different durations for patients in rooms that essentially received more daylight than rooms that didn't receive daylight after myocardial infarction. And they found that as a result that female patients stayed 2.3 days in sunny rooms versus 3.3 days in dull rooms. And obviously what they're calling is a dull room is one that didn't get nearly as much light because it wasn't facing the right orientation. They found that, and that was interesting, as the research report said, that women generally do less well after this type of procedure than men do. So it was interesting that this effect was so pronounced for women. There was no difference in male patients. And I put the table here so you can see what the measurements were. Those are in lux. So you can see that in the north-facing rooms, there are 20 to 40-foot candles roughly, or 200, 400 lux. The south-facing, obviously that's where you're going to have more of your daylight. They were in the neighborhood of 120 to 130 foot candles in the summer. In the winter, because of this in Canada and inner reflections from snow, they were in the neighborhood of 250 foot candles. It's worth pointing out here that I don't think that more light was the case. I don't think that just by giving people more light, that is what the root cause was. Obviously, it's probably something to do with the spectral component, and there's even some non-lighting benefits. There's associations of view to the outside and those type of things. So I think it's worth pointing out that as another lighting professional has said, after I've showed you some research, I also want to highlight the two cautions. One is we as an industry, lighting people have to stop making vague claims about the effects of lighting on productivity and health, and we need to look at the plausible mechanism. So while I think that the daylighting played a role here, again, I would not say it was the more amount of light. There's probably a couple of different things here: more light, possibly this in the spectrum, and then also non-lighting aspects of it. We also have to accept as an industry that many activities, lighting conditions are just one of amongst the many factors that influence the outcome, and I tried to hopefully make that enough of a caveat. Next slide, please. So that brings us back into interior lighting. TRoffers, this is a picture of an interior office with TRoffers. You're all probably sitting under a troffer right now, if I had to guess. There's roughly one troffer per person in the United States. They're the most common light fixtures in hospitals and healthcare facilities. They represent 50% of all fluorescent fixtures. The reason why I highlight those details is that there's tremendous energy savings potentials with TRoffers right now. I tried to talk about some of the benefits of new lighting through the circadian and daylighting, but now I want to focus really just on TRoffers and the energy savings potential. Next slide, please. So in terms of efficacy, we talk about that's similar to cars and miles per gallon, and efficacy for lighting is light output per watt. So the current TRoffer fixture output efficacy is about 66 lumens per watt. The reason why I chose a graphic here of a Honda Civic, because we're not trying to say that fluorescent lighting is bad. It's actually pretty good. It's like a Honda Civic. But new fixtures are anywhere between 85 and 120 lumens per watt. And I use the Prius there as an example, as a comparison. One, because it's more efficient, and two, because the Prius also has other benefits besides energy efficiency, operating quiet mode, and those type of things. And that's, again, while we're seeing huge energy savings through new lighting, there's also other things that you can put in these fixtures, new types of sensors, more use of controls, whether or not you want to put a CO2 sensor in there. I know that John, in some of his hospitals, he likes LED TRoffers because, as he says, they're essentially sealed to the grid, and I know that's an infection control mechanism. He and I have looked separately trying to see if there's a way to monetize infection control related to lighting, and I get to find one, but I know that's something that he likes, and he can speak to the benefits there, but I always like to try to highlight there are benefits besides energy efficiency. They just happen to be abundant energy efficiency potentials with these fixtures. Next slide, please. And that brings us into the Department of Energy's interior lighting campaign. So this is, again, where Department of Energy is partnering with BOMA, the IES, and IFMA to encourage either new construction or the retrofitting of TRoffers. Retrofit could be with tubes, kits, or entirely replacing the whole fixture altogether. The interior lighting campaign's current goal is 100,000 TRoffers by May of 2016. This is 10,000. This would be the equivalent of 10 million square feet of lighted area, or about 500,000. 5 million kilowatt hour savings. It's also about $500,000 in electricity savings if this goal is met. Next slide, please. The benefit of being of the interior lighting campaign is that we have a lot of information on our website. These are just some quick snippets. Again, we have a TRoffer specification, so if you need an RFP, you can download the specification, and essentially it can be the draft basis for your RFP, providing performance requirements and color quality and some warranty requirements to help you to weed out some of the stuff that's less reputable versus the good stuff. New technology is dynamic, it's changing. We also provide reports and fact sheets. So if you're trying to, if you have questions about either how do LED tubes fare in TRoffers, we've published some, we've referenced some reports published by the Department of Energy that provides a lot of information on how some of those tubes perform. We also have developed a list of data of incentives that we've called from across the country. We also can provide some limited technical assistance. Again, if you have questions about what you're doing, if you join, we can help provide information. Next slide, please. So benefits and features of participants, I tried to touch base on a lot of them in the previous slide. Really, we can help identify sites. It is in a campaign, so we do want to recognize people for their good efforts. So if you have an exemplary site, you can join, and you can also possibly be awarded an award for exemplary energy savings for TRoffers. So if you have an organization that is very award or recognition focused, that might be something you might want to do. I mentioned all the campaign websites on the last slide and the recognition awards already. Next slide, please. This is the final slide of the lighting campaign. As I mentioned, the campaign just started at the end of May. We're having a webinar where we'll go through a lot more on TRoffers, and we'll have actually a specific amount of slides on the difference between retrofit kits, the tubes. Many people are being inundated with manufacturers preaching the value of LED tubes as a quick way to get energy savings for minimal cost. We're going to talk through some of the technical issues there, also provide some limited flow questions of when you should consider one or the other, things you should ask, that type of stuff, as well as we'll hear from other sites that are currently in the process of renovating or installing new TRoffers, and they can provide some specifics on some of the things that they're finding or challenges they're running into. Current phase 1 of the interior lighting campaign runs through May of 2016, and there's our URL. If you have questions or if you're interested in joining, you can click on that and that'll take you to the right place with the right information. Next slide, please. And at this point, I turn back to John Jay for Q&A.
Yeah, thanks very much, both John and Michael, for those presentations. At this point, we would like to open it up for Q&A, so if you've been holding on to a question, now's the time. Since we have not too large of a crowd, about 20 of us on, I would like to open up the lines. So if you have a question, go ahead and you can either raise your hand through the webinar interface. There should be a little button there giving you that option, and I can unmute you. Or you can type it into the question panel as well, and I can read it out loud to either John or Michael. And I am going through here and unmuting people as well, so feel free to jump in with a question if you have one. Okay. Well, I can jump in and start things off, at least. John, I know you mentioned HCAP scores, and I was wondering if you can give any specific examples of a lighting upgrade directly affecting any HCAP scores. I believe when we spoke earlier, you had mentioned a lighting project in the basement of your Presbyterian. I don't know if that's one you want to refer to, or if you had another one in mind. John, are you there? Okay. We might have some trouble with John's audio right now. Michael, can you hear me? Okay, I think we're having some audio problems here. Holly, Kristen, I saw you had some questions and unmuted you. Can you hear me and speak now?
So, John, this is Holly. Can you hear me?
I can hear you, Holly, yes, but nobody else.
Okay. I had just put in a clarification question about the interior lighting campaign. If folks are doing lighting upgrades on their properties and they're just doing a couple of different places, maybe even just a couple of floors at different hospitals, can they still join the campaign, without doing their whole portfolio?
Okay. Michael is saying, yes, I received a text response from him, but we can't hear you via audio, Michael. He says, yes, it is scalable. And Michael and John, I'm working to try and get your audio back up and running again. It may be best if you try dialing back in, see if that works. Kristen, did you have a question too? Are you able to speak right now? Okay. Daniel Rogers, I have a question from you as well. Would you like to speak up and offer that?
Sure. The question was just whether the slides, PDF copies of the slides, would be provided to participants who attended.
Yes, we will be posting these online afterwards, along with a recording of the webinar and also a transcript. So an email will go out when those are available.
I appreciate it. Thanks, John.
Sure. And Mike Carter, it looks like you had a question on here too. I've unmuted you if you'd like to go ahead.
John?
Hey, Michael, yeah, are you back on?
Yes, Mike Meyer. I
Great.
dialed in directly from my cell phone. I'm connected still. Holly had a great question. So yeah, the interior lighting campaign is meant to be scalable. We want, if you have as few as one or two, we really would need two just at a minimum, but to as many hundreds. It is completely. We have many different methods for participation. If you want just basic, even not even for on the awards end, but before you get to the award side, yeah, as many as TRoffers as you're currently doing, and we do understand, especially some healthcare organizations might be mammoth, and obviously can't undertake a whole portfolio-wide upgrade. But yeah, so it is extremely scalable.
Great. Other questions here, feel free to keep them coming, folks. I've got one from Sydney Geiser. So Sydney, I can unmute you if you'd like to go ahead and ask.
Hi, can you hear me?
Yes, I can hear you.
Great. Related to the interior lighting campaign work that John D'Angelo discussed, were the changes communicated to clinicians before the project started to obtain buy-in? And what kind of communications were used, if so?
Good question. John, are we able to hear you? I haven't heard your voice in a little bit. Okay, I think we might have him right now. John, are you there?
I'm here. Do you have me?
Great. Yep, I can hear you.
That was
Were you able to hear
interesting.
Sydney's question?
No, I've been trying to get back in for the last 10 minutes or so.
Okay. So Sydney's, would you like to repeat that one, Sydney?
Sure. My question was related to the interior lighting campaign. Were the changes discussed with clinicians prior to the work starting to obtain buy-in? And what type of communications were used, if so?
Okay, so I'll take this one, Michael. Less than, I guess, or greater than just for an individual campaign, but whenever I'm doing changes anywhere, then I always try and engage the staff and make them part of the change. I just really strongly believe in engagement and transparency. So I actually worked with the primary users of the space, whether it was an administrative space, a nursing space, or a physician space, In fact, it led me into further and further conversations on different things, because you can always find somebody who's excited about an opportunity to have their ideas put forward. And in my case, I ended up forming a partnership with 3 surgeons, a cardiothoracic, a pediatric, and an orthopedic surgeon. And we did all kinds of really fun things with lights in the operating rooms that became surgeon-led as opposed to facilities director-led. So I do highly recommend engaging your end users.
Okay. We do have one question here from Mike Carter that I can read out loud. He sent it via chat. He asked, what advantage does LED edge-lit or light guide products offer, either in energy or light quality terms? Maybe you'd like to take that, Michael?
Yeah.
Well, all right. So the advantage of, well, LED, we can start there, just side light, edge lit, or depending on how the TRoffer itself is lighted. The LED itself, LEDs have gained in efficiency. So as I mentioned earlier, fluorescent, we've pretty much reached its maximum efficiency, and for the most part, depending on what you're doing, your LED, your fluorescent is going to be about 60 to 70 lumens per watt. LED, we're seeing on for the most part 80 to 110, 120 lumens per watt. So right there, you're probably just converting from fluorescent to LED. You're going to pick up a 20 to 30% efficiency just right there. The difference between the methodologies and how the LED produces light, being edge lit, for those who may not be familiar with that term, imagine exit signs are the best way to think of it. This is where you have a very thin surface area, and they're putting a series of LEDs right along the edge, and they'll slide in the exit sign directly there. I think one of the primary benefits, in my opinion, of an edge-lit the fixture is form factor. It allows you to really, if plenum depth is a really restriction, edge-lit would actually allow you to save that. Versus being surface or top mounted inside the trough or inside the fixture and lighting down. There are some optical differences, but it gets into some kind of I don't want to say semantics is not the right word, but some preferences. You can get some slightly different optical patterns done through the different ways you design an LED fixture. I would say that appearance and form factor would be the primary benefits of an edge-lit LED fixture, in that you can, again, the form factor would be thin, and in appearance, again, you can do things like, depending on the way you're doing it, you can make it be a see-through fixture. You can do all kinds of stuff with it through by edge lighting it, and it can just have a different look to it. So I would say that the primary benefits are appearance and form factor. There are some limitations in some things that you run into when you choose that option.
Michael, could I add a couple of things? This is John.
Please, John.
I tend not to be a big fan of the appearance of most edge-lit. They tend to be very industrial looking, but I like to use them in immunocompromised areas because they are really a true flat plate, and you can seal them to your grid. There is absolutely no air that will pass through those units for the majority of the manufacturer's edge-lit products. LEDs in general are a little bit better at keeping the stuff that's up in your interstitial and not allowing it to come down into your spaces than are fluorescent. But the edge-lits are literally just a flat panel where they fit into the grid.
Great. Do you have another text question here? This one's from Yasin, asking if, John, maybe this one's for you. Do you normally model the effects of LED retrofits to HVAC loads? For example, reduced load on cooling, increased load on heating?
I do not. I've never found it to be significant in a healthcare setting. You know, the real big difference, and it's a great question, by the way, the real big difference is on how they get rid of waste heat. Essentially, all light sources are equally inefficient. I mean, an LED is still about 90% of its energy goes into waste heat. It's just that it's a much smaller amount of energy, so it's a much smaller amount of waste. You can't run an easy bake oven off of an LED the same way you can off of an incandescent. If you have downlights or something in a low ceiling space and you have patient care areas that are under those downlights, because of the way that the incandescent gets rid of its waste heat, or fluorescent for that matter gets rid of its waste heat, you can make those spaces in the path of that light fairly uncomfortable. But it doesn't really increase your overall building HVAC load. And same thing with an LED. It tends to get rid of its waste heat through conduction to the heat sink, and then convection from the heat sink into the surrounding areas. But it's just it's not a measurable impact to even a small MOB, let alone a large hospital's HVAC load.
Great. We have about 4 minutes left, and I thought I might want to return to the question I had for you earlier, John, about example of lighting directly affecting HCAHPS scores or patient experiences. Yeah, do you have a particularly great story you wanted to share, or maybe not?
I actually did. I had shared 2 great stories up until I realized that I was on perpetual mute and nobody else could hear me. So one I talked a little bit about, and even without going to LED, if you have dimmer circuits on your nursing units, you can affect a higher rest score or a higher quiet at night score if you're using Press-Ganey to help model your HCAHPS by just raising consciousness through dimming of the lights. You know, the benefit of the LEDs, especially the generations of LEDs that are on the market now, they pretty much come off the shelf as dimmable. It's a little bit more difficult to go back and retrofit an existing non-dimmable fluorescent fixture and make it dimmable. Not impossible, but at the point where you're going to do that, you really want to look at maybe just upgrading to an out-of-the-box, off-the-shelf dimmable LED fixture. So that's one area, is the quiet at night. The other area is the cleanliness area. And I think we all know that no matter how often you clean, if it looks old or it looks bleary or it looks bleak, it doesn't look clean. And one of the examples I had at Near Presbyterian, we had some major patient corridors that we came back in. We did some very minor upgrades, new drop ceiling, new lighting, painting on the walls, and some floor repairs. And the night and day difference between what was and what is now resulted in not just patient experience improvements, but employee engagement and employee experience. It was not a depressing adventure to walk through the halls anymore. It was uplifting, and that's what I think we're all trying to achieve in healthcare.
Okay. Looks like 1 minute, and maybe we can squeeze in one more question. This one's, again, from Mike Carter. The question is, the 2010 version of guidelines for design and construction of hospitals and outpatient facilities that requires medication safety zones and pharmacy areas to meet stringent lighting requirements to avoid medication errors. And the question is, are codes like ASHRAE 90.1 accommodating this? So let me know if you need me to repeat that.
Yeah, no, that's an easy question, and yeah, they are accommodating that. For healthcare, 90.1 has several exclusions because they understand that you know, the services delivered in healthcare are not the same as are delivered in a typical commercial building. So you have some opportunity for exam lights, et cetera, et cetera. And the 90.1 is also applied typically over a much larger space than just a medication prep area. And beyond the 90.1, those lumen recommendations, as Michael had mentioned, are also contained in the RP29, and the RP29 is referenced by FGI as the code that they recommend that you look at.
Okay, great. Well, I think that will wrap up the session. We're at 2 o'clock Eastern. So thank you, everyone, for joining. And as I mentioned before, these slides, recording, and transcript will be posted on our website in the coming weeks. So an email will be sent when those are posted online. And here are everyone's contact information if you'd like to reach out with another question or request for more information. So thank you again, and have a great afternoon.